Hello everyone, welcome to my channel. Hope you are doing great. Today we are going to solve the problem single number 2 of InterviewBit, which comes under the section bit manipulation. In the previous video we have discussed the previous version of this problem, which is single number. In that problem we had every element repeating twice except one. But in this problem, every element repeats thrice, and there is single element which repeats only once, and that number is called the single number. The single number occurs only once. Every other element occurs thrice. So how do you solve this problem? So these kind of problems generally we tend to solve using hash map. You store the count of every number in a hash map, and whichever number has the count as 1, you will return it. But that takes a space complexity of big of n, where n is the size of the array. So that's not recommended actually. We are going to solve this problem using bit manipulation. So we are given an array like this. 4 is repeating thrice, and 6 is repeating thrice, and 5 is repeating only once. Now I have written all the binary representations of these numbers in an order. First 5, 1, 0, 1, and so on. So this is the single number in this array. The 5 is a single number in this array. Every other element is occurring thrice. So we start from this position. And go towards left, and at every position we check how many ones are there at that position in the whole array. As every element is occurring thrice, the number of ones will be a multiple of 3. The number of ones will be multiples of 3 because every element is occurring thrice. I'm talking with respect to excluding the single number, and I'm talking about the remaining part of the array. Every other element is repeating thrice, so the number of ones will definitely be multiples of 3. So here the number of ones is 0, which is 0 is also a multiple of 3. So, and the corresponding bit in the single number is 1. So if we consider the number of ones in the whole array, including the single number, that turns out to be not a multiple of 3. 1 is not a multiple of 3. So we can conclude that the particular bit is set in the single number. Had it been a 0, if we had a 0 instead of 1 here, the number of ones wouldn't change, right? It will be multiple of 3. So if the total number of ones in the array at that particular position, if it's a multiple of 3, then we can conclude that the bit is not set in the single number. If it is not a multiple of 3, we can conclude that the corresponding bit is set in the single number. So the total number of ones is not a multiple of 3, so we can conclude that the bit is set. Next we move on to the next bit, and at this position how many bits are set? we have the total number of ones in that position is equal to 3, and 3, this 3 is a multiple of 3. So what did I say? If the number of ones at a particular position is a multiple of 3, then we can conclude that the bit is not set in that single number. So as we can see here, the bit is not set, and then we will move on to the next position and count the number of ones in this position. 1 2 3 4 5 6 7. We have 7 ones here, and 7 is not a multiple of 3. So what can we conclude from this? The bit is set. The simple logic is, I'm writing this down. If number of ones at a position is a multiple of 3, implies that the bit is not set. If number of ones at a position is not a multiple of 3, then we can conclude that the bit is set. This is the logic. Now let's have a look at the code. I explained previously to you that we are going to maintain a pointer, and we will move that pointer towards left each time. I have explained it using a pointer, but how do you achieve it in the code? You can achieve this by taking one initially and left shifting this one every time. If you left shift this one once, it becomes this. So the pointer is now here. If you left shift it twice, if you left shift again, then it becomes this. Now the pointer is here. So this, you can use this as a pointer. So for each position, how do you count the number of ones in the given array at that particular position? So initially we will be here, and how do you count the number of ones in that particular position in the whole array? So what will you do? You perform an AND operation with every number in the array using this current variable. If the AND operation gives you 0, that means that the bit was not set in that particular number. If it does not give you a 0, it indicates that the bit was set in that number. So you do this for counting the number of ones at each position, and you check whether the number of ones are multiples of 3 or not, and you do accordingly as I stated before. If the number of ones at a position are multiples of 3, then the bit was not set in the single number. If the number of ones at a position is not a multiple of 3, then that indicates that the bit was set. So you use this for coding it up. So how are our integers represented in memory? Our integers are represented usually using 32 bits. So I am running a loop for 32 times. Each time I am left shifting 1 so that the pointer moves left each time, and I am maintaining a count variable which stores the number of ones at a particular position. Initially I is equal to 0. For I is equal to 0, it will give us the number of ones in this position. If I is equal to 1, it will give us the number of ones in this position, and so on. And you get the 1 count after executing this loop. If the count is not a multiple of 3, you will set the bit in result, right? At that particular pointer, you will set the bit, right? And you do that by this operation. The pointer, anyway, the pointer has 1 in its binary representation. If you do an OR operation with the result, the bit will be set, and finally you return the result. This is the code. I hope you understood the problem and solution. Thank you for watching this video. Thank you very much.